introduce yourself?
My name is Jared Masick. I'm a welding instructor in the United States in Spanish Fork, Utah. My school that I teach at is Maple Mountain High School.
So it's a high school level,
Yep, high
secondary
school.
school training program.
Yep, we teach sophomores, which is 10th grade, so they're about 15 years old,
Yeah.
all the way up to 12th grade seniors, and they're usually 17 or 18 years old.
So give us a little bit of background about your studies in college and your work on virtual welding.
Yeah, so I did my undergrad in just technology and engineering education. I got hired here right out of high school at this school, and I've been here ever since. Right about 5 years after I graduated with my bachelor's, I went back to school for a master's of technology, and I focused my training on helping high school students learn how to weld with different assistants. One of the things we used was sort of an in-process welding training aid. It had a special helmet, and it had an arrow to adjust your rod angle and an arrow to help you speed up or slow down. And the welder wore a pendant on their hand to keep track of that in real time. So as they're welding and they're burning their electrode or MIG welding, the pendant was telling them to speed up, slow down, or change vertical or horizontal with their gun angle or torch angle.
So is this commonly referred to as virtual welding?
Yeah, so they typically have like now augmented reality and virtual welding where you're doing it in a screened environment. There's like more specialty computer equipment. The one I was using was more of a real life. You can use it as a simulation where you're just traveling and it would still tell you, but you could also be welding in real time. At the same time, it would give you those adjustments. So instead of me being in every booth correcting the student, I have 30 students in my class, and so it's hard for me to get everywhere. If I give one student 5 minutes of my time to just one-on-one instruction, I don't see that student again for about 2.5 weeks to give them another 5 minutes based on our current structure. So the idea was if they could be getting in-helmet instruction as they're welding, that I could almost be in their helmet with them and correcting their rod angle and travel speed.
That's with virtual welding.
Yeah, virtual welding, and this one was an actual welding process. So they were getting actual welding process while also being coached to do that. Now, there are several companies that have augmented reality where they use like a cell phone or an Oculus, where they're in a virtual reality environment or augmented reality environment, and they're learning how to weld that way, and it's telling you the exact same thing as far as rod angle, travel speed, arc length. Those things are being displayed on the screen to help the student adjust in a video game kind of esque environment. The training that I went for in my master's was along the real life in-person training aid, which allows them to kind of simulate it, but then also they're allowed to strike an arc with an actual welding electrode and get that adjustment in real time.
So many proponents of the virtual welding, which I agree in, by the way, suggest that investment in virtual welding can save a lot on the material costs necessary to train a welder. Now, and which I also believe. The question I get though is, how much can we actually save?
It's an indefinite savement, theoretically, as long as your virtual or augmented reality equipment doesn't break down. The longevity of it, you can have a classroom set, theoretically, of virtual or augmented reality welding systems, and they could be in a clean environment learning the proper mechanics. There is a research that proves that with the proper mechanics taught in a virtual environment, then you put them automatically into the welding booth and they certify just as fast, if not maybe a little bit quicker, than those who are spent the entire time on actual welding. So if someone's actually learning how to strike an arc and burning that rod over and over and over again, you have the waste of electrodes, plate, all that material, electricity, lights, fume extraction. In a classroom environment, if you're using virtual or augmented reality, you can essentially cut all that initial learning cost. Then the student is primarily tasked with, once they finally get to the booth, just to strike an arc. After they strike an arc and they learn what that mechanics is like, And we all know that for those who've stick welded, know that mechanics is a challenge.
Right.
But after we learn how to strike an arc, they go back to muscle memory that they learned in the quote unquote video game
Right.
of the system. And so then you don't have to waste as much material through that learning process.
Right.
Now the initial cost of virtual or augmented reality is pretty intense. It can be fairly high, but eventually you're going to hit a net return or a return on investment. That's what the term is. And it just really depends on how many trainers you're doing and how often you're running these machines around the clock when that ROI comes back to you.
Yeah.
But after you pay it off by not buying equipment or electrodes and plate, then you'll get there. Now, you still need real life equipment. We all know that. We can't just send somebody who's virtually welded or augmented welded onto a girder and tell them to do their job.
Right.
So we still need both. We need virtual equipment, augmented equipment, plus also tangible welders with real live arcs.
I wonder if you could give us a little tour through your high school shop here.
Yeah,
Tell us what
forgive
you've
the
got.
mess. It's a little on the messy side,
that's
but
all
we
right.
try and keep it clean. We have 14 actual welding booths. Each booth, excuse me, each booth has 2 welders. A constant voltage welder, which will do our MIG and our flux cord welding process. And we also have a constant voltage or constant current welder that will do our stick and TIG. And so all of our booths are set up this way so that as we transfer from one process to the next, we just plug in the welder we want to use. If a student's working on it in first period for stick welding, third period they could be working on flux cord, and the next day they could be over on TIG welding, and then switch the wire out and go back to MIG. So all of our booths are set that way. They're a little bit on the smaller side, 4 foot by 4 foot, with an adjustable height table and a positioning arm to get the welds out of position. Sure. We use just a simple beam clamp welded to a pipe to help tighten down on that. And most of our booths are that way. I have fabrication tables. Each process that I teach my level 1 students, I give them about 4 or 5 welding assignments to get the basics of it. And then after those 4 or 5 assignments, they build a project. They fabricate using that process. So for gas tungsten arc welding, we have about 4 assignments for our entry-level students, and then they build a simple cube that they're held to dimensional tolerances on. As we move on to stick welding, they have about 5 assignments on stick welding, and then they build a simple boot scraper to kind of get the mud and off your boots. It's just a handful of parts of metal and simple welds. We build a coat rack with flux cord arc welding, and then our final project the students work on is GMAW or MIG welding, and then they build a stool. Let me see if I can find one of our simple stools. Well, we build a lot of the equipment we have. Once our students know how to weld, I kind of build what I need. You can tell all our fabrication tables are built from students' projects.
Sure.
So as they progress and maybe they don't have the funds to build their own project, I say, you know what, I need more welding tables. I'll fund that, and we're going to go through the process and the layout of fabrication on something larger, maybe a little bit more intense than we normally do in our curriculum.
Okay, so you've got how many students and how many welding booths?
So I've got 14 welding booths, plus I have, if we come around the corner, I have a handful of portable welding stations and tables. So in all, I probably have around almost 40 welders and machines. I have about, my classes cap out at 30 students. Okay. And I'm solely in charge of those 30 students. I don't have another adult assistant. Sometimes I can get my seniors or those in proficient in welding that have taken my class before to be a teacher's assistant. Trying to find an assistant is almost crucial to helping me be in multiple places at once. And so when I hire a TA, I make sure they're proficient at fixing machines, troubleshooting those machines, and giving demonstrations. While I'm busy, they're also busy. And it's a pretty chaotic when you have 30 students, all 14 booths going at once. The idea is that when one welder is welding, the other partner is cutting material or prepping their material, and then they switch. And so I try and make them weld simultaneously. They just take turns going back and forth. Some students want to do all weld the first half of the period and you can weld the second half of the period, but that never is as productive as them just really pushing that welder to be always arc on.
Okay.
Yep.
Okay.
So we have about, if you look at our exterior walls, that wall to this wall and that wall to over there, it is a 60 by 50 shop. So we have about 3,000 square feet. That includes our welding, fabrication, storage, tool room, gas room, all that's inside that 3,000 square feet. So it's a tighter space, but we do make the most out of what we have. Everything is on wheels so that I can be more modular. If I need to put a trailer in here, nothing is too heavy that I can't just unlock the wheels and push it out.
Your tables were on the wheels.
Yeah.
There, yeah.
So that's where we have the portable welders, is because we do want to emphasize more on fabrication, not just welding coupons. We know that welding those pieces of plate enhance our repetition and muscle memory, but the joy of building something you've designed from scratch is something invaluable as the students go into the workforce.
How about other shop equipment like shears and iron workers and that kind of thing?
We have several oxy-fuel setups. That one's in repair right now. We're fixing a hose on it. We have several chop saws, abrasive and cold cut with carbide teeth. We have 2 track torches. We have a plasma track torch and an oxy-fuel track torch that we can cut and bevel welding plate on for certifications and that kind of practice. We acquired a forklift not too many years ago. We didn't always have one, but that helps with material handling safely for students. We have 2 horizontal bandsaws, a 10-inch version and a 12-inch version to cut all our material up to spec. The students are taught and encouraged how to operate this, checked with safe understanding. And when they build their stool project, they are in charge with their partner to cut the material by themselves. So it's teaching them how to use a tape measure repetitively and make those cuts accurately. Then we also have an iron worker that has 3 stations technical on it, a power cavity on the end for punching or notching, a power cavity in the middle that can be used for braking material. They also have an angle iron notch in the center cavity, and then a bar clamp down here to cut our flat stock. And then we have, for fabrication wise, we have a CNC plasma cutter where we can design projects, and then students can clean up the material and weld it together in different ways. And then down this area we have more fabrication. We have a couple tubing benders, a mill drill combo, some notching equipment for tube and pipe, belt sanders, pedestal grinders, angle grinders with magnetic tables. Trying to keep the kids utilize our space as much as possible, but also make sure that they're not showering each other with sparks and being safe.
Right.
It can be hard in confined spaces, but we make it work. We do have welding screens. If you want to go right up here, we have these modular welding screens. So if we are doing a lot of fabrication out there and someone's going to be welding all period long, to avoid flash burn and things like that, we will pull down these welding screens when needed, use them, and then again put them up out of the way to maximize our space, because it is, like I said, a very tiny space to get 30 kids working in at a time. But we just try and make it as modular as possible, so we fix it to, or fit it up to whatever class period's doing that day.
So you mentioned flash burn. Do you want to talk about that a little bit? Because what we see is a lot of practices over there where people might be exposed to flash burn.
You know, the helmet sometimes can be rather cumbersome. Maybe doesn't fit in tight spaces, and so I have students that at least one a year will try and push that limit. Even though I talk about welding gives off 3 types of light. That's visible light, stuff that we can see, ultraviolet light, which is given off by the sun, and infrared light, which is the heat radiation. Those 3 types of light are very intense and about as strong as the sun. I tell my students to close their eyes and look up at a light, and they'll notice that they can see the light through their eyelids. They can see that it's light instead of dark. And I'm letting them know that even though they're welding and they might squint their eyes, that UV light that's given off by the welding arc is still penetrating the eyelid and will sunburn the cornea, the retina, the surface of your eyeball. It's very unpleasant. A mild case of flash burn or sunburn on your eyeball will feel like a couple grains of sand or eyelashes stuck in your eye, and it's very annoying and painful. A severe case of flash burn where they're welding over and over and over again without proper protection can render them eyes swollen shut, extremely red and irritated. Oftentimes medical attention is needed. Heavy medication is used, an ointment on the eyes, and it takes a few days for it to subside. Where a typical mild case of flash burn might be maybe 12 to 24 hours and it'll go away. But that it's real. My students trust me for the most part, but once a year a student will say, oh, I will squint and I'll pull the trigger. It's still penetrating your eyelids and they still suffer those consequences. Hopefully it's not as bad, but I'll take responsibility for them, and I'll ask them where their safety glasses was, where their welding helmet was. They're like, well, I was underneath a car and I was welding my exhaust and I couldn't get there with the helmet. I couldn't see what I was doing. And I'm like, well, you need to figure out a way to really protect your eyes, because in the long run that can cause permanent damage, and you're going to need those eyes for the rest of your life.
Yeah, that's a good message. Okay.